Good. Thank you very much for being here so early. As advertised, I'm Chris Wiggins, and I split my time between Columbia and the New York Times. Let me know if you'd like my lab to be somewhere else. Good? OK, cool. Good. And if you don't remember anything else, just remember that we are hiring. So chief data scientist at the New York Times. So first I need to tell you what I mean by data science, and then I'll tell you where data science would be within the New York Times. I am old, so I use an old definition of data science. This is a definition from my friend Drew Conway when he was a graduate student here in New York City, and he was listening to people planning for a Strata conference, which you may know Strata is happening right over yonder in the Javits. Planning for a Strata conference, and he heard people talking about how hard it was to apply machine learning to some sort of domain. So you have machine learning, this academic discipline, and then you have all these places you'd love to deploy machine learning that don't seem like, character recognition or places where you could use machine learning. That craft or that pain he saw as a particular new science. And that's how we think about data science at the New York Times, applications of machine learning. We still believe in Drew Conway's left-hand side, the danger zone, that there is science there. And if you just torture the data without principles, the data will confess to anything. So you really need to be scientific and skeptical about the way you deploy machine learning. Another ancient definition is from Jeff Hammerbacher, just so I know my audience, how many people know Jeff Hammerbacher, who he is? Nope, one person. All right, so Jeff Hammerbacher was one of the first people to create a BI group at Facebook. How many people know Facebook? Nobody? Good. So Jeff went to graduate school with, undergraduate with Mark Zuckerberg, and then he went to Bear Stearns for a year and got deeply bored and called up Mark and said, do you have anything interesting? And Mark said, yes, we have lots of data. So he went to go help out. And Jeff wrote this ancient document in 2009 about data scientists. He said, at Facebook, we felt like titles like business analyst, statisticians didn't cut it because we wanted a team where people might be doing multi-stage processing pipelines in Python, hypothesis testing, regression, designing and implementing an algorithm in Hadoop, which was the style at the time, or in communicating the results to members of the company in a clear and concise fashion. It is fun to look back at this description a decade later and see what's changed. We are no longer descending into R for our machine learning. Our machine learning is happening in scikit-learn, mostly, and TensorFlow. The multi-stage processing pipeline is still in Python. We're not using Hadoop. We had a pretty intense and fraudful relationship with Hadoop, and now that is Google's problem because we're on GCP, and so everybody's writing in BigQuery. So there's distributed MapReduce happening in the background, but it's Google's problem as to how to do that, not our problem. But the thing that's still the same, and the thing that makes many companies want to have a data scientist group is communicating in a clear and concise fashion to something, which is one of the things I hire people for. Can you make other people understand what you did and how it's useful? Right, so like I said, there's less so much happening in R. Now it's happening like TensorFlow or scikit-learn. And then the Hadoop is really happening in GCP. So over the last few years, we've moved a lot of our data infra to GCP, Google Cloud Platform, which means for the analysts and for the data scientists alike, we're typing SQL. And again, there's distributed MapReduce happening in the background, but we don't need to know about it. OK, so that's a little bit about data science. I need to say, before I show you examples of data science at the New York Times, it would help to say where in the New York Times the data science happens. You may not think that New York Times is a natural place to have a data science group if this is what you think of when you think of the New York Times. This is what New York Times looked like on its birthday in 1851. Now I need to tell you about where you put the data science group within the org chart of the New York Times. To do that, I have to show you the org chart. So here's the org chart. Church is the people who possess and defend the craft of journalism, and state is everything else. And I am everything else. I'm not doing data science to produce journalism. I'm doing data science to try to make the company be economically strong so that people who possess that craft can keep thinking about journalism. And in particular, there is a group called Data. Data has impact all over the company, both in the business functions and in helping journalism and in helping editors maintain process efficiency. But I want to make clear that we are not using data science to produce journalism. I would say, when I was introduced, there was a reference to this tagline. So we develop and deploy machine learning solutions for newsroom and business problems. So developing and deploying means I need to hire people who know how to extend machine learning methods. So it's not just straight out of scikit-learn in Python. We might have to make a new method slightly. And deploy means I need people who are full stack. So rather than having a data science group that then says to a software engineering group, now you pick this up and you make it work, I have to hire people who are able to know enough machine learning but also know something about deploy. And a lot of our infrastructure changes, including just moving everything to GCP, has made it a lot easier for the data science group to be a full stack group, a full stack data science group. Good. So also in the intro, it was said a little bit that I would talk about different types of machine learning. I find this a useful way of talking about machine learning to technologists and non-technologists alike in my group. Are you asking my group to do something descriptive where you have a bunch of data and you'd like a summary of it? Are you asking us to predict something of interest? Or are you really asking us to prescribe to you what is the right decision to make? And a lot of times a non-technologist will come to you and say, I want you to cluster my users to find the soccer dads and the NASCAR moms, but what they really want to know is who should get the green button and who should get the blue button. And as you talk to people, you end up realizing that a lot of time what they want is some decision support rather than just an exploration of data. Now, within my group, among the technologists, I say, shh, descriptive modeling is really unsupervised learning, predictive modeling is really supervised learning, and prescriptive modeling is really reinforcement learning. So those are the technical terms you may hear machine learning people use for these different problems. How might you think at a high level about when you do these types of learning in a company? Often when somebody gives you a complex data set for the first time, you explore it, you try to make sense of it. That's a time when you would use descriptive machine learning tools like unsupervised learning. As you actually deploy something, you might try to do something that predicts what people are going to do. For example, you might want to predict who's going to subscribe or who's going to churn. That's a predictive case in which you can use straight up supervised learning. But at some point, you start figuring out, OK, I want to try different things out. And then I will want to learn what's the optimal action for the right person. And that's the case for reinforcement learning or prescriptive problem. Now, of course, the same rules apply as in science, which is as you build a model, people change their behaviors and you realize that things are wrong. This is a bit of the ops, is when you monitor your machine learning, you see what goes wrong, it helps you understand your users better, and it helps you go back to the drawing board and think about what you should be doing. This is also the place where you need to think about infrastructure and design choices. For your ops, you need to think about the primitives of doing machine learning. There is a training stage where you're learning. There's a scoring stage. Some API is going to be hit or some scores are going to be assigned to people. There better be a testing stage where you validate your method. Not everybody wants to do that because it may turn out that your method is not working or that your users have changed their behaviors. And for each of these stages, for each of these primitives, you need to decide, am I trying to do this fast or slow? If I'm doing it fast, maybe I need a contextual bandit that learns on the fly. If I'm doing it slow, I can have a process that just runs every month, rescores people or something like that. And scale, like do I need to serve this to all the users of the New York Times, or is this something that just needs to be hit 7 times a second or something like that? And then I will make very different infrastructure choices and very different ops choices. And cost, of course. So like at this point, we're using GCP, which Google Cloud Platform, so we need to think about which processes are the expensive processes. OK, so now I can show you some actual examples of things that we do. So an example of description. The New York Times has many readers. They come from all over the world. They engage with different topics. The coverage is over a variety of topics. The New York Times has a couple of revenue streams, subscription and advertising. And when marketers from another company come to the New York Times, they want to know who even reads the New York Times and what do they read. So we built a tool to try to explain who reads what where, which we called ReaderScope. ReaderScope allows marketers to drill down and say, OK, well, I want to know what are the topics that are trending in Los Angeles, what are the, or Houston, and what are the topics that millennials are reading, and who's really reading about wine or something like that, which means we have to build a topic model, we have to understand our audience, and then we have to render it descriptively. This is an example of something that doesn't need to be refreshed every 15 minutes. So the infra for it is very different than the infrastructure for, say, a contextual bandit. This has been very useful, though, for helping marketers outside the company to understand who reads what where. Where might you want to predict things? Well, you might want to build a model that, as I said earlier, predicts which readers are going to become subscribers and predicts which subscribers are going to leave the company. That is a prediction of what's going to happen in the absence of treatment, though. It's not a learning of what is the optimal treatment in order to get what you want. That's why I say it's predictive rather than prescriptive. But this is a typical thing that you'll see in any company that has a subscription service, is they'll want to know who are the people who are going to churn and who are the people who are going to acquire. Now, of course, it's nice to know who are the at-risk individuals, but my team, my collaborators in product or marketing, they want to know not just who are the at-risk individuals, but what are the risky behaviors. So we need to balance between models that are performant and also interpretable. And that also has consequences in terms of how we, as machine learners, decide to attack the problem. Can't tell you what the super cool stuff is, but that's part of our job, is to communicate to everybody else in a clear and concise fashion, what did we learn about what typical behaviors are associated with acquisition and retention of subscription. Another example of a predictive problem is advertisers would like to know that they're showing their advertisement on something that's relevant context. So if you are a particular brand and you think that your brand is resonant with people who are reading a certain type of story, you might say, okay, well, I want my advertisement to appear in the travel section or in the sports section. However, in the digital age, even though that worked well from like 1851 until 2011 to say target people by the section they're reading, in the digital age, you may have a very different type of contextual interest. And so one of the things we said is it would be great to know, can you target content by saying this is content that is, you know, a light and entertaining story, or this is a serious news story, which is difficult to do because, you know, I can't make editors go in and tag every story as all the different feelings people might feel. But I could actually crowdsource it. So we had this fun summer intern project from a couple of summers ago where we literally crowdsourced it. We sent a bunch of stories to online crowdsourcing workers and asked them what feelings they felt after reading the stories. And we thought, well, this is a fun data set, but how possibly could you predict it? And behold and lo, you actually get a predictable score out of it. You actually can predict who's, not who's feeling which feeling, but which articles evoke which feelings. So how did we do that in terms of infrastructure? I had said earlier that a lot of the data infrastructure had changed over my last 6 years. There was a time where we were doing everything in Hadoop in our own machines. We had a relationship for a while with Redshift. At this point, over the last few years, a lot of our infrastructure has been given to GCP. So the stack is both Google BigQuery in terms of the data engineering, but also Google in terms of the deploy. So we're highly leveraging GCP for the different stages. This is a typical data science deploy stack for a problem that is slow and slow, meaning training of the model is slow and scoring of the model is slow, and user changes are slow, as opposed to, say, recommendation. When we have something like recommendation or personalization task, that's a different stack, so it's leveraging GCP, but it's our own APIs written in Go. You know, we're testing out Google Cloud ML, and we're looking forward to the day when we can do something that's high scale and low latency for everything as well. But for now, we're using our own home-rolled API infrastructure deployed on GCP. Visually, what does that look like? Well, it means like our developers, our data scientists are developing in GitHub, deployed, Dockerized, deployed via drone, and then the data engineering, as I said, happens via BigQuery. Scheduling of regular processes happens via Airflow, right? So the time scale of something that's going to be retrained or rescored every 15 minutes or every 24 hours, that's fine to have a scheduled process. Our Airflow is within GCP, so it's really managed by Google. And this is a typical data science platform for something where things are slow, meaning every 15 minutes or so. Less so for something that needs to be quicker. So we actually built a set of models. The models varied, so there were sort of simple models for NLP. There were complicated models like deep learning. Again, deep learning was leveraged using GCP and TensorFlow in order to score these different articles. So it started out as sort of a fun science project, and at the end of the summer intern was able to show that we actually can predict which articles evoke which feelings, and then our friends in advertising said, sweet, I can monetize that. And so we started collaborating with advertising to turn this into a product. So the product is, instead of saying, I want to show my brand just to articles in the travel section, now you can say, I want to show my advertising to articles that make people feel inspired. And we can do that and turned it into an advertising product. And so if you want to read more about that, it was covered in a bunch of places, but one is this story from Pointer about how we did it. What does the crowdsourcing look like? So the crowdsourcing means we actually show people a story and then give them a couple of radio buttons. And in the end, over 2018, we scored a bunch of different feelings. and it allows us to move away from targeting individuals and targeting the content. So it's not a statement about who's going to feel which feeling, it's a statement about which articles evoke which feelings. So this was a highly successful product, which we were able to do by productionalizing a machine learning model. So that was an example of prediction, but as I said, as it was introduced, we also have a set of problems which I call prescriptive, which is to say, sometimes when you work with a machine learning team, it's not that you want them to predict what's going to happen in the absence of treatment. You actually want them to know what is the optimal treatment in order to drive some outcome you care about. So 2 examples of something where there's prescription or some sort of decision support. An older one is started in 2014. So in 2014, the New York Times wrote this report about innovation, which if you're interested in innovation, I encourage you to check it out. It was a report written by the Newsroom for the Newsroom. So really, the intended audience was like 3 editors in the Newsroom. That report was promptly leaked to BuzzFeed, so now we all have access to it. It's a pretty good report. And it says, first sentence of the first paragraph is the New York Times is winning at journalism, which is how you know it's a report by the Newsroom for the Newsroom. Second paragraph, we're not keeping up at the art and science of getting our journalism to readers. So one of the things we started working on with an editor in the fall of 2014 was how can we provide some science to the way that the New York Times thinks about audience development. So audience development is the way we internally referred to the relationship you have with a story after you hit publish. So in ancient times, when you hit publish and you send it to the presses, that was the end of your relationship with the story. That's why people use the phrase, stop the presses. However, in a digital age, you might actually want to continue a relationship by thinking, how do I promote this story differently? So you might want to think about, should I be posting this on Facebook or Twitter? And if so, which sub-channel should I be posting to? So we built a predictive model, which is fun, but we can't get editors to fire up Python and run that model. So then we have to think like product people. Fortunately for us, editors at the time were falling in love with Slack, which is very programmable. So we built a Slack bot, which can recommend what stories you might want to promote and can even interrupt you if you wish to make a suggestion. So that's an example of something where you prescribe what you might do rather than merely predict what's going to happen. A related prescriptive problem in content is recommendation engines. So the New York Times has a limited personalization experience right now. But an example was dealing with election coverage. So election coverage, particularly when you have a national election cycle, that means you have many, many different elections happening across the country. And the New York Times writes a lot of stories about elections when that happens. You could either ask all the editors to think really hard for every story. Is the story of interest in Alabama and Ohio, or Michigan, or just Ohio, something like that? Or you can let go and let data. So we did a little of both. We worked with editors to define particular widgets or areas of the homepage and particular pools of content that might be candidate articles to put in that area. And then we developed a contextual bandit solution. If you don't know contextual bandits, it's kind of like an A/B test that dynamically upweights the winner. And if it's contextual, that means it not only learns what's the winning article, it learns what's the right article for a particular region. Or you could use any sort of context, attributes of the person, attributes of the content, attributes of the geography. In this case, we were interested in geo-targeting the content to different sections. Similarly, there's a section called Smarter Living. So that was another example where we wanted to show different content to different people, and contextual bandits are the machine learning solution. In terms of our ops, that's a case where we want fast, and big scale. Right? So that's a much harder ops problem than some of the other problems I showed you. We need it to learn, every 15 minutes or so, it retrains a model. We needed to score it for everybody, and we needed to show it to everybody who gets to the homepage. So that's a more challenging design problem. Okay, those are some examples of prediction, description, prescription. What did we learn? Some of the things that we learned was people, ideas, and things in that order. Like, we're trying to be helpful to other people, so we need to have good relationships with people, more important than the infra, which is sort of a thing, as much as we love the thing. The other thing we learned is it's fun to have fancy AI, but you can't really bring AI into the rest of everybody's process unless you have really good data infrastructure. So that's a lesson we've learned a lot over the last 6 years, is make sure that your data platform is correct. Make sure that your data engineering is correct before you try to build some AI that's going to change people's process. You can do AI that's going to be a provocation, but if you really want to change process, you need to think first about good data engineering. I've said a little bit about predictive, prescriptive, and predictive already. The other thing I would say about the people, though, is we've learned to treat data science as a set of different skills. So in Jeff Hammerbacker's original definition from 2009, a data scientist was doing everything, right, and very full stack. At the New York Times, we have separate groups: data science, data engineering, data analytics, data governance. All those groups work well together. We all sit together, but we all have different tasks. For example, our data governance team has been heavily involved in thinking through what data do we even need to keep track of. How do we use data in both internally, such that internally and externally, everybody feels comfortable with the way that we're using their data, particularly people's personal data. In an age where we're trying to build subscribers, we're optimizing for trust, and so we need to think carefully about the way we treat our data. Yes, but these are separate groups, although, you know, and often in academia, these groups are conflated. At the New York Times, these are separate groups that have to work well together with each other. And as I said, those are the lessons I've learned about machine learning and machine learning ops. If you'd like to know more, those are my various email addresses if you want to know more. And as I said, most important thing to remember is we're hiring. We're building strongly in AI, data engineering, software engineering. If you're interested, please do talk to me. And with that, I think I have time for a few questions. Thank you. Any questions? Please.
Is something if you can share as you develop the practice and the whole infra with GCP, can you share like some of the challenges the team was facing with the content, volumes, processing, etc. And now what kind of MLOps capabilities you're seeing emerging, which has made that whole end-to-end pipeline much easier for you guys?
I mean, the pain is different for different projects because different projects have different needs in terms of scale, speed, and cost, you know, fast or slow learning, descriptive, predictive. So there's different pain for every project. One pain is always replatforming. So as we move different pieces of the stack from homegrown or AWS into GCP, there's always some systems integrations challenges, which are exciting. None of those pains are comparable to the joy of fast, reliable SQL access. So just to have fast, reliable SQL access for a large number, like many data analysts, and a smaller number of data scientists who want to work with the data analysts to like work through pathologies in the data and try to understand places where your mental model of the data is at variance with how the data really are gathered. Having fast, reliable SQL access has been the game changer at the fundamental, which has made all those little hiccups totally bearable. Please? I mean, at the time, we had a combination of AWS and homegrown solutions. It was very early days for GCP, and GCP was willing to work with us. I think we found a lot of bugs, we found some kinks, which Google was able to work with us to work through. You know, like we were sort of stress testing GCP in early days. So I think we just had a really good relationship with GCP as we built it out. And it's just very user-friendly. So again, like there's a couple of data scientists who, you know, have a particular need from their data engineering, but there's a much larger set of data analysts, and those much larger set of data analysts are meeting a much larger set of editors and product owners. So the dominant use case is not like your fancy contextual bandits. The dominant use case is fast, reliable SQL access. Like, can everybody know that when they're going to execute a query, it's going to come back with the right answer, and then it's going to come back, right? As opposed to like, if you have a Hadoop solution that you've homegrown, right, and you have like queries that just fail gracelessly and silently, right? It just makes your whole relationship with data a fraught, painful relationship.
Thank you.
Sure, please.
You mentioned the need for full stack data scientists. What do you see as principal challenges of staffing your team with specialists who focus on engineering, deployment, modeling, analytics, etc.?
So with regard to the last one, analytics, we try to collaborate well with a much larger data analyst team. In terms of the challenges, part of it is hiring from a diversity of backgrounds. So a lot of these people are coming straight out of academia. They're pretty good at machine learning. They may not have engineering experience. In 2019, they know that they should, or at least the people I hire know that they should. And so they're all hungry to partner with the team members who really have more experience in engineering and software engineering. I would say another thing is it's been very helpful to us to choose a vendor where we're just, okay, we're going to put everything in the same cloud. So like we're using GKE, you know, GCE, BigQuery, like it's basically all just Google's problem now, all the infrastructure and fundamentals. And that's made it a lot easier for people to become full stack, is because there's less systems integrations headaches to worry about.
If I could follow
Please.
up, what do you think is wrong with the situation where you have somebody who just knows modeling, somebody who just does the engineering, and interfacing between the two, instead of having full stack?
Yeah, in a platonic universe, nothing. In terms of the way real human beings work, just in my experience, that's not the way human beings work. Like, they have love and ownership for their thing. Most of the people I hire are people person. They actually like collaborating with each other. And it's just very difficult for somebody to say, like, I own this thing, and then now it's your problem, right? So people use the phrase throwing over the transom to mean, like, okay, there's a communications portal between two people, but they're other sides of the same door. I just don't find that people like working in such a way, like, in a way, and I know that that's contrary to the whole idea of microservices and separations of concerns, but like, as we're all trying to learn how the data work and trying to build a product and like, actually work with people to make sure you're building something people want, I actually find communications is really useful. So we have, I wouldn't say full specialization, but we definitely have a team in which different people excel at different roles, and we try to, transfer knowledge a lot by having people collaborate on things. But I guess the problem with full specialization is it's often associated with handoffs. And handoffs is a dirty word, which we try to avoid. I want co-creation. I want people to be working together from the beginning.
Thank you.
Sure. Time for one more question? Please.
So I think what level of friction is there between the data scientist developing the model and then being able to deploy it in an actual predictive context?
Yeah, so the question is, what's the level of friction between a data scientist deploying things? I think it depends a lot on the performance demands on the product. So again, in problems which I call slow learning, so the training is slow and it's only rarely that a user gets a new score or something like that, then it's much easier, and we've worked with our data engineering team for them to set up a generic solution so we could just use the same infra for different problems. For something that's more demanding, like personalization, we have to work very tightly together. So we're fortunate that we sit a few meters away from the team that runs basically software engineering along with machine learning. So those people are far better than us, far better than we at software engineering. That's the part where we sometimes have to rewrite something in Python and Go, or at least we have to learn enough Go that we can work with an API at present. Maybe in 5 years or 2 years, there'll be a different solution. But those frictions, again, I really think they're about people stuff. So as much as I love the things, it's really the people stuff that you need to get right. And at this point, we're working with somebody who's a totally sane and easy to work with collaborator who leads those software engineers. We all sit together, we work well together. So we really try to co-create rather than ever try to have a handoff. I hope that answers the question. Basically, there are separate groups: data engineering, data governance, data analytics, machine learning, supporting software engineers, and we all have to work well. We all get to work well together. So we try to hire people who are good at being team players. For products like that, we try all to co-create the algorithms and the deployment of the algorithms. Okay, we're about out of time, so.
Yes.
Okay,
Great.
thank you.
Thank you very much, Chris. That's fantastic.